good afternoon, good evening. This is Mr. Payne bringing you Unit 1, Lesson 9, Structure, Understanding What You Are Given. The more you are able to see structure in the various expressions that you deal with, the easier it will be to manipulate complex expressions. We will work with the structure throughout the course. We can now look at some larger structural issues that include equivalency. Let's take a look at exercise number 1. Exercise number 1 asks you to consider this complex expression. We want you to write, in the first exercise 1a, write an equivalent trinomial expression. Test the equivalency with a value of x. Show the test. So the first thing we're going to do with this problem is go ahead and distribute. So we're going to have x times x, which is x squared, x times 4, which gives me a positive 4x, plus 2 times x, which gives me 2x, plus 2 times 4, which gives me 8. Our middle terms are alike, so we can go ahead and add them. So I have x squared plus 6x plus 8. Now what they're asking you to do is go ahead and test. Pick a number and test. So our number that we're going to use, let's call it 2. Our test number will be 2. So I'm going to take 2 and I'm going to plug it in right in that expression. So I'm going to say 2 squared plus 6 times 2 plus 8. 2 squared is 4, plus 6 times 2 is 12, plus 8, which gives me 24. Now if I take 2 and I plug it in to this expression in all three of these spots, let's see what I get. I'm going to just draw a little line down here and do my test down there. I'm going to get 2 times 2 plus 4 plus 2 times 2 plus 4. So 2 plus 4 is 6, times 2 is 12. 2 plus 4 is 6, times 2 is 12. So 12 plus 12 is going to give me 24. This test proves that this equation, or this expression here, and this expression up here are equivalent because when they are tested out, they come up with the same answer of 24. Now, I would like you to write an expression that is the form of a product of two binomials. I think you need to understand really clearly what this is asking you for. It's asking you to break this down and simplify this to have two binomials. This is just a little bit of a different way of reading and seeing these problems. What I want you to look at right away is, do I have anything inside my parentheses that is exactly the same? And absolutely I do. My x plus 4 and my x plus 4 are exactly the same. So what I'm going to do is I'm going to pull those out, and I'm going to just pull out one of those. So I have x plus 4. Now if I take the other things that are left, I have x and plus 2, and I'm going to make another parentheses with those. X plus 2. This is already in the form of double distribution. So remember when I had a foiling problem or a box problem, I called it double distribution. I took this x, I put it out front. I took this 2 and I put it out front over here. I'm distributing it twice. This is the answer they're looking for. They're asking you to have the product of two binomials. So here's the product of two binomials. All right, exercise number 2, write an equivalent expression that is in the form of the product of two binomials. So what I would like you to do is, same thing as what we did in the first exercise, see if there's anything exactly the same. In this case, the x plus 4 and the x plus 4 are exactly the same. So I'd like you to take that and I would like you to pull that out. And you can say factor it out if you would wish. And then what I'm going to have you do is create another parenthesis, a parenthesis inside that. I'm going to have x minus 5, close my parenthesis, plus x minus 2. Now what kids need to really be careful of is this right here. Not to forget that I am adding those two sides. I'm adding that x minus 5 and that x minus 2. Make sure you bring that down. If not, you're going to forget and you're going to be multiplying and you're going to make giant mistakes. So I have x plus 4 out front. Now let's simplify inside. X plus x gives me 2x. Negative 5 plus negative 2 gives me negative 7. There is my product of two binomials. That's my two binomials. Now let's go ahead and test that. All right, let's pick the number. Let's pick a number 1, and I'm going to go ahead and put number 1 into the expression, the original expression. So I'm going to have 1 plus 4 times 1 minus 5, parenthesis, plus 1 plus 4, 1 minus 2. Alright, so 1 plus 4 is 5, times 1 minus 5, which is negative 4, plus 5 times 1 minus 2, which is negative 1. 5 times negative 4 is negative 20, plus negative 5, which gives me a negative 25. Now I go ahead and use that same test number and I plug it in for the new product of binomials. It's going to give me 1 plus 4 times 2 times 1 minus 7. So that's going to give me 5. 2 times 1 is 2 minus 7 times negative 5, which is going to give me negative 25. Both of these expressions are equivalent because when I test them out, they are the same. We're going to jump to exercise number 4. Rewrite each of the following expressions as an equivalent product of two binomials. So what I would like you to do is go ahead and continue just to work on your fluency. So let's do A together. What do I see that's exactly the same? I see x plus 5. So I'm going to take that x plus 5 and I'm going to pull it out. So I'm going to have x plus 5 in my first parentheses. Well, what do I have left? I have x plus 7. So I'm going to go ahead and put that into your other parenthesis, x plus 7. Now if you want to continue to go ahead and multiply it out, it's x times x, x squared, x times 7, positive 7x, inside 5 times x, outside, or last ones are is positive 35. And now you can use your box method double distribution like it was already set up. But I think this is just showing you what it looks like as a trinomial. Just to show you this case, it's 12x plus 35. You can get there doing the same thing here, but they're asking you for this right here. I think we should be able to stop right here today. So it's saying x plus 5 times x minus 7. That is a product of my binomials. Let's look at B. Example B, I have x minus 2 exactly the same, so I'm going to go ahead and pull that out. And what do I have left over? I have 3x minus 4, so I'm going to put that in my parentheses. Example C is a little tricky, so let's take a look at it. What do you see that's exactly the same? Well, you say, Mr. Payne, I have x plus 4 in this parenthesis, but there is no parentheses on the other side. So let's create the parentheses on the other side. Now I have them in parentheses. And what positive number is invisible sometimes that can sit out in front of parentheses? Well, if you said 1 can be invisible, you would be absolutely correct. So now that we've formed our parentheses, it's a little bit more visible that there's a positive 1 that sits out in front. So let's go ahead and pull my x plus 4 out. And what do I have left over? I have negative 2x and a positive 1 left over. So I'm going to say, all right, negative 2x plus 1. So the product of my binomial, x plus 4 times negative 2x plus 1. All right, now we're going to get a little bit more complicated. We're going to take a look at the x minus 4 and the x minus 4 on both sides that are exactly the same. So I'm going to go ahead and pull that out, x minus 4. Now what I want you to be careful of is this. What do I have left over? On the left-hand side, I have 2x plus 1. On the right-hand side, I have x plus 6. But don't forget to bring down your minus sign, because I am subtracting the 2. So it's x plus 6 on the right-hand side. Make sure you have your double parentheses in there. Before you try exercise number 5, please make sure that you have C and D done for class so that we can start there and check to see your work and see if you're understanding what's going on. All right, let's now take a look at exercise number 5. Remember that we want to always look for mindful manipulations in order to help us solve our problems. So that means tying into what we did in lesson 8. Sometimes we won't know whether those manipulations will pay dividends, but as long as we know we are making manipulations that retain equivalency, then they are worth a try. Exercise number 5. The binomial 4n plus 1 is equal to 7. And what I try to do is I always circle these or underline the key information. For some value of n. What is the value of the expression shown below for the same value of n? Do not solve for n in this problem. Use mindful manipulations and look for structure to help solve this problem. So we're going to tie in lesson 8 and lesson 9 together. So the first thing I want to notice is that I have 4n plus 1 on both sides. So I'm going to say, all right, I'm going to pull that out front. 4n plus 1, and I'm going to pull that out front. Now what do I have left over? I have 3n plus 1 and a positive n plus 2. So I'm going to have 3n plus 1. Please remember to have your plus sign in there, and n plus 2. If you're asking, Mr. Payne, where did you get that plus sign? It's right in there. Make sure that comes down. So now, what did they say 4n plus 1 really equals? They're saying that 4n plus 1 really equals 7. So I'm going to go ahead right now and put that in there. Alright, now what I'm going to do is just keep that in my parentheses. Now I'm going to say, alright, let's go ahead and finish solving the right-hand side. 3n plus n is going to give me 4n. 1 plus 2 is going to give me 3. Alright, well, does that help me with my mindful manipulation? Well, a little bit. I know I have 4n plus 1. How can I get 4n plus 3 to say 4n plus 1? Well, I can say plus 2. So now I'll add my plus 2 out here. So I can rewrite this as 7 times 4n plus 1, because that's what I want it to change to, plus 2. So if I take that plus 1, make it plus 2, it gives me plus 3. So really, what is 4n plus 1? It is 7. So I'm going to have 7 plus 2. 7 plus 2 is going to give me 9. So I'm going to have 7 times 9, which gives me 63. This is a tough problem. Exercise number 5. It is carrying 2 lessons and putting them together. Now I would like you to make sure you write a good WSQ. There were a lot of little tricks and hints in here and a lot of procedures that could help you with this problem. Have a great afternoon.